Okay. Don't forget, I got some extra office hours today if you need some last-minute help. No problem. 4:30 to 6, my office. Okay. The agenda today, I will definitely want to do one more example, complete example with you about how to use the O keyword and twin and deep twin, the combination of all this kind of good stuff together, and you want to make sure you can use them properly in your contracts. And then we'll do some exercises together, interactive. So we're going to criticize on different postconditions. And then if time permitted, we'll go to a new topic. All right, let's start. Okay, this is basically the the second last topic. The last topic last time was the bond diagram, but this was the second last topic. So this is basically all the different ways for you to write postcondition. Remember, you can only use the O keyword in the postcondition. Only in the postcondition you talk about the difference between pre-states and post-states. Okay, that's the first reminder. So we talk about all these possibilities. I assume you kind of get some idea, but we now try to reinforce the idea today using another example. Okay, so this is something I would expect you to actually reason about yourself, right? That's what we did last time, thoroughly. Okay, let me leave you with that. If you got trouble, please let me know. What I would like to do now is to apply what we have learned so far about O keyword, also copies of the objects, and see how we can combine together into a different example. And remember the bank example we did in the first 2 classes. We're going to extend that example a little bit, okay, do something that's more complicated. Before we only talk about withdraw, deposit, it's not that interesting. Let's bring another class into context. Okay, let me just go over this slide here. When are the contracts complete? So this is my expectation on you, okay? So there are 2 kinds of questions I can ask you in the exam. Number 1, I will simply say, write a postcondition for this particular query or command, in which case you want your answer to be as complete as possible. I'll explain what completeness really means in just a moment. The second type of question is, I might give you some existing question with postcondition. Existing postcondition is a question. And then I'll ask you to argue whether they are complete or not. Okay, that's the exercise we'll do towards the end of today. Okay, we'll make sure you're comfortable with both kinds. So what do I really mean by completeness? Okay, basically, again, in the postcondition, you will use the O keyword most likely. And then you should really talk about the difference between pre-states before the feature implementation is executed and the post-states after it is executed, right? And then, now, the tricky thing really is your attributes or variable that you're concerned about may not just be primitive type like an integer or Boolean. If that's only the case, it's not too difficult. It's really about composite structure. For example, you have array, linked list, or array heap, or sometimes an even more complicated structure. Okay? And of course, integer Boolean, they're very easy. Sometimes you don't even need to use deep twin. Using a twin will just be able to copy the whole thing. Okay? Okay, here's the rule of the thumb. Every time if the postcondition, the intention for the postcondition is really to argue if a particular command or query, especially command, is correct for an attributes. Okay? What should we do? Number 1, you want to make sure the intended change I'm trying to make. Maybe I only want to change a particular spot in the heap or in the array. First of all, make sure that particular spot is changed. That's only a small change. Number 2 is the most important part. You want to make sure the rest of the structure is unchanged. That's the most difficult part. Because for that part, you have to somehow to say, in the pre-states, in the post-states, these kind of remaining parts are exactly identical. So that's the tricky part. We're going to see example to make it concrete. Okay, for the second part, it's really usually tricky because you got aliasing issue. So which copy should you use? And also, you got iterable simply means some structure that's composite. You have to go through element one by one. We'll talk about iterable, like an iterator pattern, after this topic. We'll do that. Okay. So now let's consider a very simple 2 classes. Okay, let's go over that quickly. Number 1, we have a class called account, and this is something you will need to do for lab number 2. You can think about redefine is like to overwrite a particular feature that's inherited. So it's equal is like the equals method in Java, nothing new. Okay? And then you would say constructor should be make. You just, let's say we have two attributes only for the account. We got string owner, we got integer balance. And then we got the constructor here, which will set up the owner. Balance should just be 0 to begin with. And then we got deposit over here, and deposit is something we'll focus on for this particular example. Yeah? Of course, you may have a precondition there saying integer amount should be positive. Let's not worry about it. Okay, that's not the focus. And also, you can have, also, it's equal. Okay, that's what you're declaring, how you're redefining that it's equal. You simply say two accounts will be the same if owner and balance are the same. Okay, very easy. Now, let's bring in another class. Okay. Bank is simply going to be a collection of accounts. So that's why things get a little bit more complicated. Let's say we have a bank class with a constructor make, and then we have an array of accounts over here, and then the make is simply just going to create an empty collection of accounts, right? And then this feature is very important. We're going to use it a lot in all the versions. Account of basically saying if I say account of Alan, that means if Alan does exist in the bank as an owner, I want to return the account objects of Alan. Okay, that's why you see the return type is actually account, not really just a string, first of all. Do you know how to implement this? It should be quite easy for you right now, right? Well, just use a loop. Okay, that's why I don't really show you the implementation. It's trivial. Let me ask you this, very quick practice. How would you specify the precondition to say, well, of course, if you want to return the account objects for Alan, Alan better exist as an owner? Anybody? But you can see this old index here, right? It's only n. N is a string. It's not an integer, right? Yeah, so would you use across some or across all? Some is obvious choice. However, I do want to point out something to you in just a moment. I'm pretty sure you can do this. You can say across the account is account, and then owner should be n, some. However, I'll write something on my iPad quickly, and then I will ask you whether it's also going to work. The one we just went through is this guy here. I simply say across the account is ACC the owner, n, right? What if I wrote it like this? I'll put in orange. If I say not across, okay, underline means keyword, across. Okay, across accounts, let's say is ACC, and then all ACC the owner not n. Okay, don't forget the closing parentheses. Do you think the orange and the green are equivalent to each other? Yes. I heard yes, I heard no. Okay, by the way, it's not De Morgan. No, it's not De Morgan. I can generalize De Morgan in some way, yeah. Okay, so, well, this may be a little bit puzzling to you, but if I write it something like this, hopefully you'll feel maybe more comfortable since you're good in math. Whenever I say for every x such that some range is satisfied, it is the case, px. Wouldn't you agree that should be equivalent to not the case? There exists x Rx not Px. Basically, double negation. One example would be if I say everybody in 3311 pass. That's equivalent to saying there does not exist a person in 3311 that actually failed, right? Double negation, right? Okay, I want to point this out. So don't be too surprised if I give you maybe two postconditions, maybe in the exam, and ask you, oh, do they really mean the same thing? Very easy question, right? Okay, I want to point out this. Okay, good. That one's not too bad. Let me go back, okay, not to be too distracted. And then, okay, I actually put it there as well. Okay, you can look at that. And I just omit the implementation there because it's not the point. Just imagine that you have some correct implementation for account of. And then the postcondition here is very easy. Result that owner is just n, whatever you return. The owner should be, for example, Alan. And then we also have another command, which is going to add a new account. And now, if I want to add a new account, what would be the precondition here? The name doesn't exist. I agree. Okay, straightforward. So I don't need to bother you with that, but you can have a look. Okay, basically very similar to the previous one, but the opposite way. Okay, and then over here, if you want to add, you can simply create a new account and then force it to the end of the array. Okay, easy implementation. And that's everything you have to know about this for this example to start with. Questions? So basically, accounts that force does not change any account objects. It simply changes the array that's being forced. It's just growing the size of the array by 1. So you're not changing any accounts. Okay? No, actually, remember accounts is actually an array class, which is a base library. It's only constrained by how much memory you have. So it's never going, well, unless you're trying to enforce too many elements into the array. Otherwise, it should never be a problem. So it does resize dynamically, but that's kind of done by the base library. You don't have to worry about, right? Okay, yes?
Is it possible to do, like, for the non-existing part,
is
it possible to make a feature called account of and make it not to check if the
okay. What you're asking is actually a very good question. I also got many questions like this for the lab 1. Let me make it clear. Okay. Basically, in general, actually it's just not about precondition, but also postcondition or invariance. Let me just say precondition, for example. In general, if I have a feature f, and then if I say require, okay, and then, for example, if I give you some tag, okay, and then I simply put to do over here, right, for you, right? Apparently, for lab 1, you have 2 choices. Either you can simply just define another feature that's called a G, and then G of something, and then you simply define G elsewhere. I believe many of you are doing this. That's absolutely fine for lab 1. Okay, no problem. However, I do encourage you later to think about usually the contract you have to write for this course. They wouldn't really require to really implement another feature because a very common drawback is, let's say this. Let me just say the case for the postcondition. Let's say I have f, and then I have ensure. And then I have some tagged postcondition over here for you, and then I say to do over here, right? I know that one way to do it is simply to say, you can simply implement another feature called h over here, and then the h is going to be defined separately. And now, in many cases, you can simply make h, this part here, just very identical to how you implement f in general. However, that kind of loses the value for contracts. What you really recommend to do is try to use across always if necessary. That would be the most complicated syntax you have to use. Use across the quantifiers, either all or some, in order to write the contract for require or ensure. That's my advice. However, unless you're otherwise forbidden to actually write a helper feature, otherwise you can feel free to do it. That's no problem. Okay. Either way works. Okay. Good. But for lab 1, either way is fine. Right? Okay, so that's the account and bank. Okay, but we might go back to them later on. But now let's tell you the roadmap for illustration. Okay, basically we're going to see how we can write complete postcondition for one of the features in bank. 5 different versions, 5. Okay, but there's a reason for 5, right? It's not a magic number. There's a reason for that. We're going to consider this particular command in the bank class. Every time you want to deposit at the bank level, you will say, for example, I want to deposit into Alan's account for $100. You have to give which owner you want to deposit into, right? That's why there are 2 input parameters. And we're going to show you basically 5 different versions. Let me just tell you the purpose very quickly so you have an idea. For version number 1, we're just going to give you, you're lucky, you will just get a correct implementation from the supplier. However, somehow the contract is incomplete. For version number 1, you wouldn't see any errors from the runtime because the implementation is simply correct, even though the contract is incomplete. You're just lucky. Okay? The version 1 just tell you, don't depend on the luck. Version number 2 tells you that we keep the same incomplete contracts. However, now we change the implementation to be wrong. This is where you're going to see trouble. Because there's something that goes wrong, but nobody is to be blamed, right? Then that's not a good design. Okay, that's version 2. And then version number 3, 4, and 5 is going to see how we can incorporate the 3 kinds of copies we learned about before: reference copy, shallow copy, and deep copy, to see which one will be more desirable in this case. So version number 3 will simply still keep the wrong implementation and see if the reference copy version of the postcondition is going to catch the error. Okay? Version number 4, let's see if shallow copy can do it. Version number 5, the final version, let's try to see if deep copy can catch that. Right? 5 versions. That's a roadmap. But we're going to see. Basically, between every version, the code structure is very, very similar, except a few changes, very minimal changes, but I'll point them out to you explicitly. Any questions about this kind of a setup? Any confusion here? Okay, so we're going to start with, all the versions are going to use the same account and also bank class that we just went through. Will be the same. Okay, let's see. So now let's say this. We're going to assume this is the kind of runtime structure we have. So we have a bank, and then we have just an array of 2 accounts. Okay. I should have changed it to 1 and 2. Let's say for now just 0 and 1, okay, the indices. 0 and 1, and then we have the first account with balance 0, and the owner is Bill. And the second account, the owner is Steve, also balance 0, just to start with, okay? That's kind of the common setup. And then, before we try to go into each version, let me walk with you some test cases we're going to run for all the versions in order to see if something has gone wrong. Okay, let's go over it very easy. Basically, we're just going to, first of all, create an empty bank. And then we're going to add 2 accounts. The first account will be owner Bill. The second one will be owner Steve. After these 3 lines, we get exactly this. Initially, balance simply just 0. After that, there's only one change we want to do. We want to say, let's now deposit at the bank level. Deposit, so of course, the deposit I'm going to call, it has different versions. That's why I got V1. You're going to see V2, V3, V4, V5. And then I just want to deposit into Steve only, and $100. A correct implementation should only modify the balance for Steve over here from 0 to 100, and that's it. You should not modify the rest of the array or the rest of the bank. Okay? That's something we want to make sure that's going to happen. Okay, and then this is a simple check. Just make sure balance for Bill is 0, balance for Steve is simply 100. So this is going to be the same test we're going to run for all the 5 versions. Okay. Okay. Any questions? Okay. Everybody follow the logic for the test. Okay. So now let's move on to first version. Version number 1. Okay, we're going to consider deposit on version 1. Okay, let's see the first one. Let's say we simply want to deposit into this particular owner with this amount. First of all, we just make sure the owner is there, right? That one's easy to write. And now this is simply just a loop. A from until loop, we simply go from the lower bound until the upper bound of the array. And then make sure if the current account we are looking at has the owner the same as the one we are looking for, right? In that case, we simply say accounts at position I, targeting that account objects, and call deposit at the account level, right? And make sure increment the loop count to I. That's it. That's the correct implementation, okay? In version 1, we are lucky. The supplier is not evil or it's not careless, right? They got the correct implementation for us. And then let's have a look at the postcondition over here. And let's see what's going to happen. And that can be a little bit quick review on the old expression. Okay, the first one is the new accounts, the size of the new accounts in the post states should be equal to the size of the old account in the pre states, right? And the second one is saying we want to make sure, one thing to, okay, let me just go to version 1 directly. Okay, that's version number 1 over here, okay? So now, one thing I want to show to you. When we are trying to call a count of over here, because we're now in the current class called bank, a count of also comes from that class. So that's why we can simply disambiguate, say current, right? It's like a this in Java. But current has an important use later. Okay, the current here is optional, but I choose to include it, okay, for a reason. You will see in later version why. Okay, so now these are the 2 postconditions. And now I want to do a very, very quick illustration to show you, okay? So now, okay, good. For the very first postcondition, okay, let's imagine how it is going to work at the runtime, okay? At the runtime, when the user actually calls this particular, let's say we're trying to make this particular feature call. The bank B over here, and then we want to deposit into Steve. So N would be Steve. And then A would be 100. Let's say that's what we're doing. So now, question for you. After checking the precondition, it will be true in this case because Steve does exist. Steve does exist in the bank, right? Precondition is no problem. After the precondition, what should we do before we go ahead and execute the implementation? According to what we said last time. Create a pre-state, yep. So somehow the pre-state is a very general term, right? It simply means whatever values for the attributes are before you execute the implementation is called pre-states. But more specifically, what IFA will do at the runtime, they will look at your postcondition ahead first and see what old expression value you intend to use later and cache them first, okay? Let's now see this. So now, before we ever execute the implementation, the first one, let's do a little practice over here. The first one, what should be the value to be cached? Would it be the counts array, or should that be something else? Accounts.count, agree? Because you can see this is the old keyword, right? And it applies to the smallest units for the programming, right? The smallest units. In this case, accounts.count should be treated as 1 unit. So this will be cached. Okay, first of all, let's understand that. So now that means in the pre-states, what we will do is, there's going to be a hidden variable. Let me just call that old underscore count. I'll put it like that. It's simply assigned to this expression here verbatim. So it's going to be accounts dot count. Just that. Okay, that's the first one. What would be its value here? 2. I agree. Thank you. So that means old count would just be 2. It's a primitive pi, by the way. Okay, now you can do the second one, which is slightly more complicated, but it's not too bad. Okay, so now the second one does not involve a loop, not yet. The second one, what should we cache? I'm talking about this particular old expression. What should we cache? Should we cache an account object? Should we cache a bank object? Or should we cache an integer? Integer. Because the smallest units of expression you have is over here, the whole thing, right? The balance. Okay, so that means you got another thing, I'll just call it O balance, right? O balance is simply assigned to current dot account of n. Now, what should be that value in the pre-states? 0, right? The balance. Oh, thank you. The balance. That's important, yes. Okay, you agree that should be 0, okay? So this is like a very quick reminder. You should really have this kind of a mental model. Every time after the precondition is satisfied, before you go ahead to the implementation, you have to look ahead to the postcondition there to see what are going to be needed later and cache them. Okay? You don't really do it manually, but IFA will do it for you. But that's why you got to be very careful what you write over there. Okay? Okay, let's do that. And then let's now go ahead and execute implementation. According to the implementation over here, it's going to do the right thing. So it's going to deposit $100 into Steve. So 100 is going to be changed over here. Okay? So now we are now entering the post states. Now in the post states, First of all, when we do this particular comparison over here, right? So now we can actually do it. Now, what should be the account? Yeah, that's good, because if you look at the current array, it's simply just 2. And then what about this particular O expression? Well, it's also 2, as we said, right? So 2 equals 2, true. So this one, check, pass. Notice that when you are trying to evaluate this expression over here, you have to look at this particular current state, which is the post states. On the other hand, when you are trying to evaluate this O expression, you have to look at whatever you have cached previously in the pre-state. That's the important part, right? Every version follows the same logic. And then finally, how about this guy over here, right? This guy. So now, how about this guy here? When you say current the account of and the balance, what should that be? 100, I agree. Basically, current is this particular bank objects, and go to accounts, account of, over here, let's assume he's going to do the right thing. So he's going to return back this particular Steve account objects. And then his balance has been correctly updated to 100, right? So that one is simply just going to be 100. I'll put green here. And now, what's this O expression over here? 0, as we cached previous. That one doesn't change, right? However, it doesn't change because there's no aliasing. When there was aliasing in later version, you might see that it may not be visible. That's a look ahead. In this case, that'll be 0 plus A is simply 100. Well, you get true. So now both postcondition pass. So version number 1 may not be so realistic. You got correct implementation. You also, although you got incomplete contracts. I'm going to explain why it is incomplete, okay, in just a moment. The reason that it is incomplete is these postcondition over here, let me write it here, incomplete because it talks nothing about all other accounts. For example, it doesn't say what happened to Bill's account. Or when we have 100 accounts, what happened to all the 99 other accounts? That's what's missing, okay? But you're going to see how serious the issue could be in the next version. In version number 1, this issue would not reveal itself because the implementation was correct, okay? Any question about version number 1? Specifically, how we go through the process of caching, right? I assume you're okay with the process, so I can be a little bit quicker for the later versions. Yes, Jordan. There's no aliasing. I tell you why. You can basically, if you want to know if there's any aliasing going on between the pre and post states, look at the expressions being cached. Okay. So now let me go just point to you. We agree that what the first value to be cached was this guy here, accounts.count, which is an integer. Primitive type has no aliasing issue because they do not store address. Also, the second one to be cached, it is the balance of some account objects, which is also integer. In that case, we also don't have any aliasing issue.
So if you were to cache an account object, is that the integer?
Then
Everywhere, right?
exactly. So you're going to see exactly that in the later version, where the O expression does not apply to just one single integer. It might apply to some accounts array, for example, right? But we will see that, yeah.
So if you drop the current from the last line, you just say all account.
Yeah, okay, good question. The question was, what if I simply drop the current? Programmatically speaking, they mean exactly the same thing. Okay, it's pretty much like Java, right? Whether you say this.x versus x, they mean the same thing, right? So if the reason I left it in is because in later version, it makes it a little bit easier for you to think about. Because you want to know, when you are trying to say this particular feature called account of, you're really talking about the current bank objects called the account of. Okay, make sense? Maybe have a look. Maybe if you're still confused at the end, let me know again. Okay, but short answer to you, if you simply get rid of this, it doesn't make any difference. It does not. Okay.
Just to make sure I understand. So if we put a bracket before all and right after end,
You mean the first one? Sorry, the first one or the second one?
The second one.
The second one.
Bracket right before old and
Mhm.
right after end.
Right after, okay.
The second statement would actually be 200, not 100.
You're basically talking about what if, for this particular post condition here, if you simply write old and then current dot account of n, and then you put something like this.
Yeah.
Okay,
So cash.
no problem. And let me put a color here. If you simply say that, and then dot balance. Okay, that's a good question. So now let's consider this alternative. If I simply say this, remember O is a keyword, right? So now what expression will be cached? An account object, right? Because now, because of the brackets, we're going to cache only this particular value, which is an account of something. That's an account object. In this case, since there's no twin, there's no deep twin, so we are making a reference copy of this account object in the pre-states. This may or may not be what you want. You gotta judge. Okay? Good. Okay, how about the last question? Yeah, I'm gonna move on.
So there will be a blueprint like somewhere in the memory.
There's gonna be
of the account of Steve.
Yes. Oh, I see what you mean. So basically, yeah, exactly. So the question was, when we try to call this particular, when we try to call this particular feature here, when it's account of n, of course, it's going to return an account objects. So this is, of course, it's like anonymous objects. It can just be used right away. So the object is not stored somewhere for you to make use of. We just use that in the post condition, right? Yeah, because in the post condition, it simply cannot say, I want to have this local variable, and the local variable should store this particular account of, and then manipulate it later. No, it doesn't work that way. You got to write a single expression. Yeah. Okay, that's about version 1. I hope everybody's reasonably happy. Okay, let's look at version 2. Version 2. Okay, for test version 1, the same test as I said before. Everything is just good. Implementation is good, even though the contract may not be so ideal. However, you will get a green bar. Okay, that's fine, right? I mean, but don't be too naive, right? The implementation can just be wrong. Version number 2. Let's see. We keep the same contracts. However, the implementation now is going to be wrong. Okay. What we will do is, imagine that the comments over here is simply whatever loop we had to write previously. Imagine that, just the loop. Okay, I just didn't put it in. But when you download the source code, you will see them there. Okay, so we got whatever that's the correct implementation before, but now we have just one extra line that will make the whole thing mess up. The extra line we're adding, we're saying that now, in addition to depositing into Steve, now go to the beginning of the array and change the account as well. Deposit into the same account amount. That's the extra stuff we're trying to do. That's apparently wrong. Now the question for you is, if we simply adopt the same contracts as before, will they be able to catch this particular evil implementation? Okay, I'm glad at least you agree, but let's see very quickly why. Okay, so now I'm going to make the illustration a little bit briefer, okay, because you already know the process from the first version, right? So now, yeah, let me just remind you. I'm going to use green for pre-states. We know that in the pre-states, we're going to cache this particular value, which will just be 2, right? And also in the pre-state, we're also going to cache this balance for Steve, in which case it will just be 0. Okay, green one is just the pre-states caching, right? That's what we said. But now, let's say we are now going to execute the implementation here after the caching. Now, once we have correctly, first of all, deposited 100 into Steve, what about this extra line? It's now going to accounts array at position, the first position, which is Bill, and then deposit the same amount, which means we're also going to put 100 here. That's a wrong thing. But now, if you go to the post condition, accounts.count will be the same, 2. 2 equals 2, true, nothing wrong. And then, if you go to over here, accounts current accounts of, so N over here is still Steve, right? What's the balance for Steve right now? 100, right? Okay, so you do the same check. 100 equals 0 plus 100. It will still be true as before. Nothing has been addressed about these objects. Okay? How this objects, which means the rest of the accounts, how this object should be changed or unchanged is not addressed in the postcondition. In the postcondition. That's the problem. Okay? So now if you simply try to run the same unit test, the same. Let me just go back to the slides. If you try to run the same thing, so now if you try to do that, are you going to pass this particular test? Specifically, will Bill's balance be 0 as expected? No. That means you're going to get some check assertion violation. But that's not good, because from the client's point of view, they saw that, oh, the system actually is misbehaving, but nothing has been caught at the postcondition. That's something that's wrong. Okay? We said that good design simply means when something that goes wrong, there should be some warning from either client or supplier, right? That's a problem. Any question about second version? Yes. Yeah, the test, yes. You mean the test itself? We may. Yeah, so the test simply say, you can see now, we are trying to say b.deposit version 2, right? Which is invoking the wrong implementation. And then after that, we want to make sure the balance is 0, and balance for Bill should be 0, unchanged, and also balance for Steve, it should be 100. But that's not the case because the wrong implementation also deposited into Steve.
So let's we have with their bid design, right? We give our application to the client, and then we often turn off our contracts, given that our code is robust and able to handle any input. You said that we can actually give them warnings, but in Java, parallelism that would be like an exception, right? Do this, but that's redundant because it just tells us it tells what's wrong versus it show us what to do. So in that sense, how does iPhone do that?
Well, apparently, basically, what's going to happen here is the implementation is wrong, right? When at the end of the day, when you want to deliver this particular bank account app, you better make sure the deposit on feature over here is actually fixed. But how can you force the supplier to fix it? They will only fix it if calling this one is going to cause a postcondition violation. Otherwise, they will never bother. Right? Pretty much like previously when we talked about the binary search and did the basic example, if you didn't have that precondition violation where you're trying to call the binary search on an unsorted array, you will never fix it. Right? So that's kind of demonstrate when something that goes wrong, you should really give a counter violation. In that case, you will force the supplier to make some change so that when everything goes well together without any counter violation, you can turn the contracts off. Right? Again, that's the same process, just a different example. Okay, good. Now, shall we look at the number 3, version number 3. So now, pretty much our lesson is, this particular version is not good because it only talks about the account object that's being changed, which is Steve. However, what about the rest of the array? Bill, for example. And imagine that if account array is simply 100 or 1,000, in which case you're only modifying one of them. What about the rest of the 999, right? That's kind of the general issue we're dealing with. Or if you're doing the heap, array heap for lab 1, if I'm only trying to change a small spot in the heap, what about the rest of the tree, right? Something like that, the same issue. Okay, so now let's go on to version number 3. Version number 3, let's now start with, let's make an improvement over here, which means not only that we're going to worry about Steve, the one that's to be changed, we also worry about the rest of the accounts. How do we do that? Basically, we have to somehow run a quantification, right? Across. We're going to say, go over the accounts array if the current account you're looking at does not have the owner that should be changed, then the account should remain the same between the pre-states and the post-states, informally speaking. That's what you should do, okay? Let's see exactly how to do it. Okay, version number 3, let's look at the code. Okay, you can see that over here, we still do the same correct implementation followed by the evil line, right? The same as before, okay? The implementation is still wrong. And then we still do the 2 checks over here that we did in the previous 2 versions, but as we know, they are not complete. Let's add an extra postcondition. What I do over here, I just call it others unchanged with tag. First of all, can you just read it first? And then I'll explain that a little bit, I'll elaborate on that a little bit further. No, now we only talk about reference copy. You might want to jump to the conclusion that we should use deep twin. Not yet. That's the conclusion, right? But we want to know why. We want to arrive at that conclusion later. Can anybody try to just explain to me in English what is others unchanged is really trying to constrain on? Just briefly. Yes? You're trying to look at the current accounts array and try to make sure it's not changed?
As long as the owner, you're going through the accounts and check to see if the owner is equal to the owner that you want to change. And then if it's not, then whatever that equals to, because it's going to be true or false.
Yeah. Getting somewhere. Oh, just let anybody want to try? Go ahead.
So we have now a copy of the old accounts.
Oh, accounts, I agree. We got an old copy there, yeah.
Okay. Then we are gonna say that all the accounts, but not the n we are targeting, they have to be from they have to be untouched. They have to be the same old values.
Okay, I can hear something. Yes, good try. Okay, yes.
If we're not currently looking at the account that we just changed, it implies that that current account hasn't changed whatsoever.
Okay, that's moving even closer. That's good. Okay. Yes.
So in this implementation, what we're basically checking is going to be the same thing as the current one because they're both objects.
Oh yeah, we're basically talking about a limitation for this particular version. That's the conclusion from this mini slide. Okay, not yet. Okay. The way I will say it, very close to what Chelsea just said, very close. I would say we consider the old version of the accounts array. More specifically, we compare the old reference copy of the accounts array. And then we want to go over that particular old reference copy, and then we say, if the current account we are looking at has the owner name the same as n, which we intend to change, that simply means that accounts, and if we're trying to find out that particular owner in the current state using account of, they should be the same. Okay, a little bit wordy, I know. Yeah, not as compact as Chelsea, but that's a little bit different take. Let's see, do you think this might work? Well, if this works, then why do we need 5 versions, right? That doesn't work, okay? Let's see, quickly, okay? So now, let's see, oh, by the way, I really want you to think about, now this really explains why I bothered to really show you the array copies example. Remember we got old imp and imp. We are basically doing something very similar to that. So that's why I try to simplify that into that particular example to introduce to you. Okay, try to revisit this example here we talk about today and that example. You will see much reinforcement. Okay, let's see that very quickly. Okay, so now if we go there, okay, let's now worry about the 2 previous postconditions that we talked about. Okay, these 2 we already covered them. Okay, we don't have to worry. Let's now focus on this particular one. Others unchanged. Let's look at that. Okay, how many values are we trying to cache over here? How many values? 1 value? Which value? Yeah, so are we trying to make a array copy, right, somehow, right? So basically, when you look at the old expression here, it applies to only just the accounts over here, like that. That means in the pre-states, as soon as after the precondition is checked, let's say there's no precondition violation, what we will get is something like this. We'll simply say old accounts, ACCS, is simply assigned to what? just whatever it is, literally, right? IFO compiler does not add anything to it. It's up to you as a programmer, right? So that would simply be accounts. Just that. What would be the consequence of doing this in the pre-state? Do we create any new objects? No. Old ACCS pointing to, oh, I beg your pardon. That's not what I meant. Point to the same array. So that means later on when you do the runtime check in the post states, whenever you talk about old accounts, it's going to be talking about the green reference, which essentially refer to the same array. Doesn't seem to be very useful. Let's see. Let's say we go ahead to actually do this particular wrong implementation, right? It's now first of all going to update Steve to 100. Oh, sorry, that's not a string. To be 100 as expected. This part is fine. And also we're going to also deposit into the beginning of the array of Bill. So that's wrong. Okay, that's a wrong implementation. So now let's try to evaluate this particular post condition. Okay? Let's try that. If you look at that, first of all, how many iterations do we need to run in this particular case? 2 iterations. Because if you look at, first of all, when you look at old accounts over here, that's what we are crossing over. Old accounts is now just pointing to just an array of 2, right? So that's why we know that it should be 2 iterations, first of all. Okay, let's try very carefully. For the first iteration, so we'll be looking at ACC.owner. What would be ACC? This particular, right, objects. That's the first one that we're looking at. So ACC.owner will just be Bill. Tilde, and what's N? Steve, remember? Okay. And as you know, this is already false. In that case, if we already got a false antecedent, do we need to bother with the right-hand side? We don't need to, okay? So this part here is automatically true for the first iteration. Are we good? Okay? Somehow, I tell you what, we are good, but this is not good because it tells you true. Although we have already changed the balance of Bill mistakenly to 100. That's not good. Even though we agree this is the correct behavior for that. Okay, now let's say for the second iteration over here, what should we do? For the second iteration, we're basically looking at this particular objects, and the owner is Steve. Steve tilde the argument, which is also Steve, and then implies something. Now, a question for you. This is true. Do we have to evaluate further? We have to right now. So now, if you look at this particular one, I know usually students having trouble with this. Let's try. Okay. So now, when you try to evaluate the consequence over here, what would be the ACC? The one we are looking at for the current iteration. Agree? ACC is exactly this guy here, right? That's ACC first of all. And then, what about current dot accounts of ACC the owner? First of all, ACC the owner is, in this case, since ACC is this, ACC the owner is also Steve. Okay? So now, what would be that expression? When you say current account of Steve, what should I return back to you? Oh, no. Account of will give you account object, right?
Checking if account owner does not equal N, so when we check for Bill, so like for Bill, it's not equal. Yeah, it's not equal. So should we check in the first iteration?
No, actually, no, in this case, no. Because remember, oh, you know what? This is not equal to, yeah, okay. But what I said was not completely invalid, okay? Let me roll back a little bit, okay? Back in the first iteration, when I asked Bill equals Steve, okay, what I meant to say was Bill is not equal to Steve. Is that true? It is true. So what I wrote was okay, right? Okay, good. Now, back to the second iteration. So now, when I say Steve is not equal to Steve. Actually, why am I trying to contradict myself? Maybe what I Oh. I got it. Why am I doing this? The postcondition itself, let me just read it again to make sure it's fine, okay? We're saying that if the owner we are looking at is not equal to the one we are trying to change, then the account should stay the same, first of all. The postcondition itself is okay. Now, for clarity, bear with me, let me do it once more. Okay. Iteration 1. Iteration 1, we're actually going to do ACC, the owner, for the first iteration is simply bill. Agree? So now for bill, now I got it. So bill not equal to, and the owner, the one we are trying to change is Steve. This is true. We agree. Good. Should we evaluate further? Yes. Thank you. So now to evaluate further, we're going to look at this particular account, right? This line here. So now the ACC that we are talking about is simply this particular account objects. Agree? And now when you try to do this particular query call, it's going to say current the account of ACC the owner. In this case, it will be Bill, right? ACC the owner, right? It will be Bill. What object would it return? It will return just the same objects. You're basically comparing the same object with itself. That's what's happening in the first iteration. That's the absolutely correct version. Say, when you're watching the recording, just skip the last 1 or 2 minutes. Yeah. Okay. Sorry about that. So now that's the first iteration, right? Now, what about the second iteration? It will be like this. It will be trivially true. Okay, iteration 1 and iteration 2. Iteration 1, first of all, I would say it is true simply because we consider the objects over here, the account objects, equal to itself. Okay? Iteration 2. For iteration 2, ACC now becomes the second one. That's the second iteration. ACC, the owner right now is Steve. Steve not equal to Steve would be, yeah, I agree. That would be false. And now, if the antecedent is already false, we don't bother to go, right? That's not the case we care. So just go. It's true. The overall, the implication will just be true. Okay, so the first iteration is going to be true because we are comparing Bill with itself. The second iteration is true simply because the antecedent for the implication is already false. Okay, good. Okay, any confusion, question, please? Yes?
You said the object is converted to itself?
Correct.
But in the pre-state it was 0 and after that it was 100.
Good question. Okay, let me say that again. Actually it doesn't matter. Okay, you're basically wondering about the first iteration, okay? When we talk about the first iteration, when we say ACC over here, right? ACC, this guy here, agree? That object has already been changed to 100 because we only evaluate the postcondition in the post states. It has been modified already. There is not a separate copy of these account objects, right? And when we try to use account of Bill, is also going to return the same object. That's why you're comparing 100 and 100 in this case, right? Yeah. To further clarify your question, apparently this contract is not strong enough. A strong enough contract should say we should really somehow store Bill's objects with the initial balance 0. And then if it has got mistakenly updated to 100, we can now compare to say 0 is not equal to 100. So that should be a postcondition violation. That's the correct version, but we are not there yet. Okay, good. Good. Let's now go back to the slide very quickly. Okay, so now let's go to, so if you simply test version number 3, okay, basically you will still get the violation, well, you will still get the same issue as before. which means Bill's balance is actually not 0. It has been mistakenly updated to 100. However, you don't have any post-condition violation. That's the problem. Okay, good. Let me just show you one more thing. Okay, just for your student actually last year actually asked me about this. Okay, I wouldn't bother you too much. I'll point to you what you should look at for this particular example. This is what we just looked at. We're basically going across the old version of the account using reference copy. Okay, there is another alternative way you can try out. Okay, which means rather than going across the accounts object itself, we're going over its indices, right? That is why you see old accounts that lower and old accounts that upper. Okay, that's another way to write it. Okay, you can study that if and see if you can that makes sense to you. I'm saying these two versions are really equivalents. Okay, you can look at that a little bit later. Okay, that will be up to you as an exercise. Of course, eventually we'll see that having only O accounts or accounts over here is not sufficient, right? We're going to see in the later version how we should improve it, possibly using a twin or deep twin. Okay, you can look at that. I'm going to make the notes available to you. Okay, let's go to version number 4. For version number 4, we got the second last version, right? So now we are still going to have the same loop structure, but now the thing that we go across over is not O accounts, but rather O accounts twin. Question for you, is this going to give us a post-condition violation as expected?
No.
Okay, that's a good sign. I heard no. Okay, can somebody just try to explain very briefly? I'll just take one answer. Yes, please.
Because you're making a new array, but the references inside reference to the same old object.
That's exactly correct. I'll just repeat what you said, right? So basically, the issue for this particular shallow copy is you're only making a new array objects, but every slot of the array still point to the same Bill and Steve account objects. So when you actually mistakenly modify Bill's balance from 0 to 100, you're still pointing to the same account object, so you cannot see the difference. That's the problem. Let me show that to you very quickly. Okay, it's quite important to see. Okay, so now let's see again. The most important step is to see how things will be cached. So now after require, okay, so at this point, right before we start the implementation, right before that, okay, we're going to, for these two, we don't have to worry about them, okay, that's from the previous version. Now, tell me something, what are we caching here? Well, apparently we are trying to cache a shallow copy of the accounts. Why do I know it's a shallow copy? Because the user writes twin, right? The compiler doesn't make any decision for you. So what is going to happen already down here, it's going to be an old variable over here, simply called, let's say, old accounts twin. That is simply assigned to this expression over here, verbatim. So that's going to be accounts dot twin. How do we create accounts dot twin? Accounts is simply just an array. So we're going to make an array over here of size 2. Do we make any further copies of objects? We do. Sorry, we don't. We don't. So I said it too quick. We don't because it's a shallow copy, right? And then this should point to Bill, and this should point to Steve, right? And that one is going to be old accounts twin, and simply pointing here. So now later on in the post condition, whenever you're referring to old accounts.twin, you're really talking about this particular array, okay? However, it doesn't really make much a difference because this green array is really pointing to the same 2 account objects. The problem is it's already beyond the first level. That's why it wouldn't tell the difference. Let's do very quick, very, very quick. I'll be careful this time, okay? First iteration. Now, for first iteration, I know that ACC is this particular object, that's ACC, right? So now ACC, the owner will just be Bill. Bill not equal to, right? You can see not equal to here. Not equal to, and then we are changing Steve. And that should be true, agree. And then we say that implies. And now ACC is exactly this account over here. Oh, by the way, I forgot one thing. Because the wrong implementation should be done, right? That means we already have deposited 100 to both. Okay, just don't forget. Okay, I just forgot that step. Okay, so now when we are trying to ACC the owner, ACC this guy here, ACC the owner, ACC here is simply this object. Okay, what about current account of ACC the owner? Same objects, because yeah, exactly. There's no new bank, right? So that will be just the same object. So here, just the same objects. So you're just comparing the same object with itself, just the same reasoning as in the previous version. Okay, so now for the second iteration, I'm pretty sure you'll be okay, right? For the second iteration for the same reasoning, it would be trivially true, just because we're now considering Steve, right? That's the ACC we are iterating through. Steve not equal to Steve is simply false. False antecedent will give you the whole thing being true, trivially. Okay, so that will just check. That's the second last version. Okay, you can see up to now we have gone through 4 versions, right? I think it really reaffirmed the story we have been telling you. You really want to have that kind of mental model in your mind when things get more complicated. Any questions?
I have a question. You see across all accounts.twine.
Yeah.
So after all, if we had written current accounts.twine, that would have made the same sense.
Okay, thinking this way. When you say, yeah, I noticed that it may appear a little bit weird on the projector, but on the screen it's fine. Okay. So here you can see across all accounts twin, first of all, right? When you say across this particular O expression, this is a value that we cached in the pre-states. So you're really talking about this particular array you're iterating over, first of all, number one. Number two, when you say current the account of, what's the current?
So like the bank.
Exactly. So the bank is now referring to this particular array. However, it doesn't really matter, right? Because now these 2 arrays are really pointing to exactly the same object. You can see this array at position 0 points to the same objects at position 0 for the other array. That's aliasing. That's because of shallow copy. Similarly, the second position in the current array also points to the same object as the second one, right? Okay.
That would have made the same sense.
Mm-hmm.
If we had written correct according to the
Yes, yeah, but let's not get there. Yeah, just a different way of writing things. Okay, so now 4 versions done. Any questions? We okay, right? Okay, now how can we get to the final version that is going to give us a post-condition violation which will signal the error? What should we do? Deep twin. Deep twin of what? Yeah, in this case, right? You can write that, yeah. Very good. Okay, let's see that very carefully, quickly. So now if you do version 4, again, it's still going to give you the same problem, right? Which means you're going to fail the test, but there's no post-condition violation. Okay. Now, let's see the final version. We still got a wrong implementation. We still got a 2 incomplete contracts, but now for the complete part, we try deep twin. Are we now going to get a post-condition violation? It would be, otherwise there will be another 6th version, right? That's kind of how you think logically. It should be fine now. Let's see. Now, this is a final version, okay? What I will do is, I'm going to draw very quickly, very, very quickly for completeness. So now, when we get to this particular point, right before we try to execute the implementation, right? We're going to look at the O expression over here. So now, what are we going to cache? We're going to cache this particular expression here, right? So that means there is going to be old accounts deep twin, basically like that. And that one there is simply going to be assigned to exactly this expression verbatim, right? Just be copied verbatim. So that will simply be accounts dot deep twin. Again, this particular assignment here is done by IFO automatically for you. You don't have to worry about it, but to understand it, you better think that way. Okay? So now, how should we draw? Well, apparently, old accounts deep twin is going to point to Should it point to the same array? No, I agree. First of all, it's going to point to a new array with index 0 and 1. Okay. So now, should these two point to the same account? No, I agree. You're not falling asleep. That's good. So now, that one should point to account. That one should also point to account, right? And this one here should be a deep twin of this, ACC. Okay. So you got owner, you got balance. In this case, owner should be bill. And balance should be the pre-state, right? It's still 0. And also, you got over here ACC, and then you have the owner and balance. In this case, that would be Steve. And then also 0. Okay, that's a deep copy. Now, I won't forget. When I do this particular wrong implementation, am I going to, which copy am I going to modify? The top one, that's the current one, right? The green one is a complete deep copy of the old states, but it's not going to be touched. So now we're going to, first of all, not only that, we're going to update that to 100, but also mistakenly update this to 100. So now you can see that when we try to run this particular cross loop, I will just do the first iteration, just the first one, right? For that one, the first iteration, okay? So now the ACC over here, since we are going across all accounts deep twin, that means we're going over this particular array, right? In the first iteration, it's now pointing to this particular object. Agree? So that's ACC, first of all. So ACC, the owner is Bill. And then not equal to, the n that we're talking about is still Steve over here. And as we know very well, that should be true, right? True antecedent means we're going to look at the consequence. Now let's look at the consequence. ACC, as we said, is exactly this guy over here. So now, when we say current, where is current? Right? Let me use a different color. Current is exactly over here. Current is this guy here. Current, account of ACC, the owner is Bill, right? Now current dot account of ACC, the owner, is going to give me this particular object, the pink. So now when you compare these two objects, are they the same? No. One has 100, the other one has 0. They are not the same. That means you have mistakenly modified the balance of Bill in this case, where you shouldn't. So this will give you the postcondition violation. Good.
Since you're using the tilde, you don't need to use that values, right?
Yes, correct. So when I use tilde, that's almost like a calling the is equal feature of the account. Remember, we already redefined that. Yeah. Question? Yes.
So you know how shallow copy copies at, like you said, the first level?
Correct.
Not everything below that.
Mhm.
Deep copy copies.
Everything.
Oh, copies everything. So like
Correct.
second-
So you can think about deep copy is going to do a recursive, going to run recursively, because in general, so because when you have objects, that means you simply store the address of some memory location. So this kind of indirection can go indefinitely. So you just don't know how you just don't know how complicated the object structure is.
creating new object for every single level.
That's correct. So deep copy simply does the copy for every single level. That's correct. Okay. Guys, are we okay? Okay. You know how many times I taught this example? 1, 2, 3, 1, 2, 3, 4, fifth time. You know, the first time I taught this example, I still remember. You know the Acrodat building, Shuri Business School? That was when I taught the summer version of this course back in 2015. And then, no iPad, no projector, I drew on the board. 5 versions. Anyway, that's just for your information. Yeah, I'm glad iPad's there. Yeah. Okay. Guys, questions, please. Any questions? Yeah, go ahead.
Two questions. First one, we're able to vary we're able to use the syntax such as CNAT across bold, but because it's a composition pattern, right? Because it's able, it extends iterable in some sense. Is that why?
Okay, so basically you're asking, one important thing to notice, which will draw a very good connection to next week's lecture, okay? Basically, if you look at that, what one important thing to notice, which will draw a very good connection to next week's lecture, okay? Basically, if you look at that, one important thing to notice, which will draw a very good connection to next week's lecture, okay? Basically, if you look at that, what one important thing to notice, which will draw a very good connection to next week's lecture, okay? Basically, if you look at that, one question for you to just ask for now. You don't need to have the answer. Whenever we say across, okay, nothing to do with old, I'm just talking about across. Whenever I say across, what kind of stuff can I put over here after S, between across and S or is? What kind of stuff can I put over here? Collection, yes, that's what I said. To be more precise, anything that's iterable. And when will you learn about iterable? Lab 2. You will learn about that very, very thoroughly. Lab 2. Okay, yeah, question? No, okay, I'll just answer it, yeah, quickly. So we still got 10 minutes. I want to do some exercise with you as well. Okay, but let me explain this. The question was, what's gonna happen if I get rid of the current over here? Okay, the answer is, it's not going to make a difference for the following reason. Okay, let's say we have already made a deep copy in the pre-state, so now we are now checking the post-condition. Let's say, hypothetically, if the current is not there, and we are trying to call a count off. Now, which array are we going to look into? Are we going to look into this array, number 1, or this array, number 2? The answer should be number 1, but why is that? The reason is very simple. Because every time, it's actually quite true in Java as well. Remember, every time if you're simply referring to a method that's in the current class, you don't have to say this dot account off. You don't have to. But somehow I put a current over here simply because it makes it a little bit more obvious to you. That means the current object you're talking about, not the deep copy version. Yeah. Good. Of course, you can feel free to put it back. Okay, no more questions? Yeah. How about I say final one? Otherwise, you can talk to me after class. Okay. Yes, please. Sorry, say that again. I didn't quite. Oh, tilde, yes. The tilde, yeah. The contents of the account. Let me. Good question. The question was, what's going to be the programming effects for tilde? Okay, tilde. It depends on whether the is equal feature has been redefined in that particular class, right? So now we are trying to do tilde between the accounts. But remember, in the previous case, we already got, if you remember when we show you the 2 classes, in the account class, we say that is equal has been redefined. To say 2 accounts will be equal if the owner and the balance are the same. If you did not have this redefinition, tilde will just do reference comparison. It's like in Java, right? Yeah. Very good. Okay, I do want to do a little bit of practice with you. For iterator pattern, let's wait until next week. Okay? But I will upload the slides anyway. You can definitely feel free to have a look. What I want to do is I want to go over with you as many as possible some exercises of writing postcondition. Oh, some exercise for you to think about. Okay, I wouldn't expect your answer for now. If you go to the end of the lecture, so I would say maybe only look at the iPad notes, right? I'm going to block out the answer over here. Okay, basically imagine that this can be also perfect exam questions. I will simply say now, let's think about to write the contracts for account off, right? And somehow I want to say, since account off is a query, it is not intended to change anything. How am I supposed to write that to say the accounts array is only going to be looked over, but not going to be modified? So I got 1, 2, 3, 4, 5, 6 different versions for you. Which version should be correct and which version should not be correct? And in the exam, it will not be just a yes or no. You gotta explain. Oh, well, no, I may not give you 6, right? I'll just say, I might give you 1 or 2, 2 or 3, something like that. Okay, think about it. You know, I already got a model answer over there on the slides, but I would say for your own sake, think about it. I do urge you to talk to me in the lab or the office hour to go over the answer, okay? Now, my office hour, anybody want to answer him? What's my office hour? Today. Oh, yeah, good. Monday, Tuesday, well, yeah, Monday, Tuesday, Wednesday, 4 to 6, okay? But today is special, right? Okay. So now, let's now have a look at some exercises. We'll do hopefully at least one or two, okay? Now, let's look at this particular query, very simple query. It's going to take an integer, returns true. Well, actually, I shouldn't say it. Well, it's quite obvious what it is supposed to do, right? Whether x is positive or not. Now, I simply say, ensure x larger than 0. Is that correct? I heard no. Wow. I tell you what, every postcondition I'm going to show you in the exercise, they're all wrong, right? I can tell you that, okay? But the critical point is, why are they wrong, right? That's what I'm expecting to hear. Anybody from this side want to try? Yeah. Well, you're basically talking about how it should be written, right? Anybody want to try? I do hear you. Okay, give it a try. Oh, you mean the tag? Oh, tag is optional. If you really want the tag, sure. I could have put tag for you. Let's say, not a problem. But the same error is still there. Okay. Anybody at the back? Yes, go ahead. Huh? Oh, actually, yeah. You know what? Wow, you guys are good. You guys are good. That's not intentional. Oh my goodness. You know what? I remember I make a mistake like this in the exam, and people actually wrote x is not defined. Yeah, actually, that's correct. Anyway, that should be I. That should be I. Now, what's wrong?
We should have I greater than 0 implies result is true.
Something like that, exactly. The general problem for this one here really is, whenever you're trying to address the postcondition for a query, you should definitely see the result. Okay? That's a general problem. But now, yes? Oh, that'll be how we fix it. It'll be another issue. We'll get there. Okay. Now, it's for those of you I know may not be every one of you is comfortable. I just want to demonstrate why writing this is very bad. Okay. Imagine that the implementation is simply just correct. Imagine. Okay. So now if I say is positive, I got 3 over here. In this case, am I going to get a postcondition violation? No, because 3 larger than 0 will just be true. Right? Agree? 3 here. If I say is positive minus 4, what's going to happen? First of all, result should be assigned to false, agree? Because it's not positive. However, postcondition should really tell you whether your implementation has been carried on correctly. What's going to happen here? Result correctly set to false, but a postcondition violation. Simply because the postcondition only depends on the value of the input rather than drawing some connection between the result, which is the return value, and the input. That's the problem. Okay? Are we okay with this? Okay, I want to illustrate to you because it's very common to write things like this. To write a postcondition for your query without even mentioning the result, right? Good. Now, how do we fix it? That's in the next slide. I'll give you a potential fix. And many of you likes to write that. Okay? I just added today, actually, because I saw that yesterday. So I thought it might be worth mentioning. Yeah. So now, let's say I'm trying to, it's now x, right? The xi problem is not there anymore. Nothing there, right? Good. So now the question is, do you think this fix would be okay? Okay, if I heard no, well, I'm saying that if x is larger than 0, the result should be set to true. No. Oh, yes. Oh, wait. You're saying that I'm missing a colon here. Huh? Okay. They take it one by one. What you guys, Shetty, maybe what you said, you said I should add a colon here. That's what you said, if I heard you correctly. First of all, please don't do this in the lab test. You'll get 0, okay? Because now when you talk about postcondition, right? You should only put Boolean expression. Having assignment will never get you a Boolean. First of all, don't do it, okay? And number 2, over here, we are really saying the following. If the input is really positive, I would expect the result to be, this is a comparison, right? To be true. Nothing wrong with that.
Why is this more false? Explicitly IFO setting the result to be false?
That's good. Okay, default value. Well, actually, default value for the result depends on the type. If result is integer, result default value will be 0, right? Yeah. I can tell you that, first of all, if you write this in IFO, it does not even compile. Syntax error. And some of you actually pointed out, the problem is, if you use the if then else, well, I already said the answer. If you use the if then syntax, you must include the else part. Because they don't know what if x is less than or equal to 0, right? That's the problem. Okay, first of all, this is a syntax error. Let me point it out. Before I show you the correct way of writing this, let me show you what I would prefer to you writing it, okay? Because we talk about Boolean expression for the contracts, I would say if you can simply express it using logical operators, I would say do it. In this case, is it possible not to use the if then else syntax? Implies, right? I will explain to you why. So now, I will simply, any suggestion? X greater than 0 implies, right? And I'm not too sure if this might make sense to you, but when you say result equals true, wouldn't that just be equivalent to result? Okay, good. If you're not comfortable with this, that's okay. You can say result equals true. I'm not too bothered by that. So now, and then, after this, you have to say some, okay, let me just put it this over here, okay? That implies result. Oh, and then, x, if it is not the case, x larger than 0, and then you would say implies, right? Not result. Let me write it. Sorry. Not result. Agree? This is a single postcondition. A single one. Okay? That's good. Okay, I think that would be good. So now, how do we fix this guy over here? So now, basically, what you got to do is to add another else over here, and then say not result. These two are completely equivalent in terms of their meaning. However, I would prefer if you can simply use the logical operators. That's my point. Okay? Do we have time? Do we? I guess no, right? Okay, I don't want to run over time. Let me just tell you. Next week, we're going to finish another 2 exercises, and then lab 2 will be released quite soon. Maybe early Monday, okay? And then we'll talk about design patterns for next week.